Welcome friends, welcome to the course of data structures. This lecture I'm going to explain a new concept called as recursion. A simple definition is a function called by itself. What is the importance of recursion in programming language? So in the concept of data structures at least, and what is the difference between iteration and recursion, and how to do the time complexity analysis for recursion. Before that, I'll give a few examples and the best how to write the recursive programs. So this lecture, I'm going to cover recursion and the difference between iteration and recursion, an example of factorial program, Fibonacci series, and in an introduction, there is one tricky program also. Coming to the recursion. So we know that factorial program. Let us assume that factorial. I would like to find the. So I want to find the n factorial. So we know that n factorial is nothing but n into n minus 1 into n minus 2 into n minus 3 into and so on 3 into 2 into 1. So I can say that this is equivalent to n into fact of n minus 1. That means factorial of n minus 1. That means I can say that it is equivalent to n into n minus 1 factorial, which is equivalent to n into n minus 1 into n minus 2 factorial. So which is nothing but n into n minus 1 into n minus 2 into n minus 3 factorial. So, and similarly we can say that n into n minus 1 into n minus 2 into and so on 3 into 2 into 1 factorial. So remember this concept. So n factorial is nothing but n into n minus 1 factorial. This is a n factorial. Now fine. So how to write generally a program? So we are as we know that a into b is equivalent to b into a according to commutative law. So n into n minus 1 into and so on 3 into 2 into 1 is equivalent to 1 into 2 into 3 and so on n. So how I can write in two ways. I'm going to take n value as some 5. I value I'm starting it as n, while I greater than 0, then what I'm going to do, so fact equal to fact into I. So then I will initialize fact value with n and I value with n minus 1. So that means this execution will be like, so my n value is 5, there is no change, fact value is 5, fine. Now so I value is n minus 1, that is 4. Since 4 is greater than 0 in first iteration, so 4 is greater than 0 in the sense, so fact equal to fact into I, that is 5 into 4, so that is 20. Now I am reducing the I minus minus because I value should be 3. So now again while loop, 3 is greater than 0, so fact equal to fact into I, 20 into 3, that is 60. I value is 2 because of I minus minus. Then 2 is greater than 0. 60 into 2, 120. I value is 1 because I minus minus. Now 1 is greater than 0. Fact equal to fact into I. 120 into 1, that is 120 only. So I value is 0. 0 is greater than 0, false. So 5 factorial is equivalent to 120. Fine. Till now it is fine. So this is recursion. The same thing I can write like using one statement. So n equal to 5 for fact equal to n, comma, I equal to n minus 1, I greater than 0, I minus minus, fact equal to fact into I. Using for loop also I can write. Or the same thing can be written as fact equal to 1, n equal to 5 for I equal to 1 to I less than or equal to n, I plus plus, fact equal to fact into I. So the same thing I'll execute, I'll show. So recursive program, control S. I'm saving in recursion, fact.c. So hash include stdio.h, int main. So int n, printf backslash n, enter n, scanf percentage d ampersand n. So for int fact equal to n, I equal to n minus 1, then I greater than 0, fact equal to fact into I, comma, I minus minus. Simple statement. So printf backslash n, factorial is percentage d fact. So control F9, fact is undeclared. I declared fact int fact equal to n. Okay, I declare fact here, fact and I also, fact and I. Sorry, control F9, control F10. Enter n value 5, it is 120. Control F9, enter control F10, 4 24. Control F10, 6 720. A simple statement I had written for finding the factorial. Now what is the time complexity of this algorithm? What is the time complexity of this algorithm? So this algorithm time complexity is, this is one time, this is one time, 2, and this statement will be executed till I greater than 0, that is n minus 1 times, and this will be n minus 1 times, this will be n times. So the time complexity is 1 plus 1 plus n plus n minus 1 plus n minus 1. So which is equivalent to 3n plus 2 minus 2, which is 3n, that is order of n or theta of n. This is the time complexity of factorial program using iteration. Now why to write using recursive? Recursion I'll explain now. So if you want to develop any algorithm for recursion, you should be in a position to design a recursive tree. So now I'll construct a recursive tree. Fact of 5, which is equivalent to fact of 5 into fact of 4. Now factor of 4 is equivalent to 4 and factor of 3. Factor of 3 is equivalent to 3 into factor of 2. Factor of 2 is nothing but 2 into factor of 1. We know that factor of 1 and factor of 0 is equivalent to 1. Now 1 into 2, that is equivalent to 2. 2 into 3, that is equivalent to 6. 4 into 6, that is equivalent to 24. 24 into 5, that is equivalent to 120. Now see how it works. I am going to create a stack. This stack concept I will explain later. Anyways, a stack also I am explaining in these videos. You can go through the stack. Now fact of n I am inserting into stack. First I am pushing the value of factor of n. I want to find the factor of n, where factor of n is equivalent to, it is popped and inserted as, this popped and inserted as, or let us assume that n equal to 5. So it is inserted as 5 into factor of 4. Now I want to find the factor of 4. So 5 is there and I want to find the factor of 4. The operation is multiplication here. Fine. Now factor of 4 is nothing but now the stack is replaced as 5, 4 into factor of 3. Now this will be replaced as 5, 4, 3 and factor of 2, the remaining thing. Now this will be replaced as
5.
That means I am giving as a here and the replacement of a here. So 5 and 4, the stack values 3 and 2 and remaining values factor of 1. So and this will be this stack will be finally having 5, 4, 3, 2, 1.
Yes.
Now see the same thing. I'm repeating now. What we have to do? We have to do the multiplication. First multiplication. That means the stack value will be having 1 into 2. That means 1 into 2. That is 2. So 5, 4, 3, 2. Now these two things are replaced as 2. Now in next step, 2 into 3. So 2 into 3 is nothing but 6. 5, 4 and 6. Now this 2 and this 3 are replaced as 6.
Yes.
Now 6 into 4. 5, 4 into 6 are 24. Now these 6 and 4 are replaced as 6 into 4, that is 24. Now then 24 into 5, that is B. 24 into 5 is equivalent to 120. These two values are replaced as 120. See, finally the stacked up value is this one. So that is result, that is 120.
Yes.
Now how to write a program for this? So remember that we had given initial value as fact of 5. So that is fact of 5 is stored into stack, then it is replaced as 5 into fact of 4. This is the stack top all the time, will be pointed by stack pointer. So I am giving arrow for the stack pointer. Whenever 120 is removed, nothing is there in the stack, stack will be empty. So now how to write a program for this? Now what we are writing a function, one function called as fact of n. What this function will return? It will return either integer or long integer or anything. So assuming that it is returning integer. Now, so a fact of n is nothing but how much it is? N into fact of n minus 1. That means it is returning n into fact of n minus 1. When if n is greater than 1. So if n equal to 0 or n equal to 1, that means if n is less than or equal to 1, the factorial is equivalent to return 1. Else it has to do this operation. The same code has been replaced like this. So now I will type the same code in C program and I will show you how the factorial will be calculated using recursion. See, Alt F8 recursive fact so hash include stdio.h. So I am writing a function called as int fact of int n. So if n is less than or equal to 1, then return 1, else return n into fact of n minus 1. Simple. Int main int n int fact equal to int f equal to fact of n printf, or otherwise directly I can print here printf percentage d, factorial value is percentage d fact of n. So n I had to read printf enter n scanf percentage d ampersand n. Now control F9, there are no errors. Control F10, enter n value 5, it is 120. Control F9, control F10, 6, it is 720. Control F10, 7, it is 5040. So this is the factorial program using recursion. Now what is the time complexity here? So the time complexity is nothing but time complexity if n equal to 1, then the time complexity will be t of 1. If n equal to 2, then the time complexity is 1, that means t of 1 plus 1, but that is 2 into that is 2 into 1, and it will be executed only once. Fine. Then if n equal to 3, 3 into 2, that means it is t of 2 plus 1, because if n factorial is nothing but n into n minus 1 factorial. So the time complexity will be, if n equal to k, then t of k minus 1 plus 1. The time taken for t of k minus 1 plus 1. The time taken for t of k minus 1 is nothing but how much it is? K minus 1 plus 1, that is equivalent to k. If you replace k with n, it is theta of n or order of n. So the time complexity is same for finding the factorial of n using iteration as well as recursion. Now here we got one function called as t of n is equivalent to t of n minus 1 plus 1. This is called as a recursive function. That means the time complexity to find the factorial of n is depending on the time complexity to find the factorial of n minus 1 plus 1, where t of n minus 1 is equivalent to t of n minus 2 plus 1. So that means t of n is equivalent to the time taken by t of n minus 1 plus 1, which is equivalent to t of n minus 1 plus, or I can write like t of n minus 2 plus n minus 1 plus 1, or I can write like t of n minus 3 plus n minus 2 plus n minus 1 plus 1. A small mistake. T of n minus 1 equal to t of n minus 1 plus 1, which is equivalent to t of n minus 2 plus 1 and plus 1, because t of n minus 1 is this one, that is equivalent to t of n minus 2 plus 2. So this t of n minus 2 is nothing but t of n minus 3 plus 1 plus 2, that is t of n minus 3 plus 3. Likewise, t of n minus k plus k. If k equal to n, then it is equivalent to t of 0 plus n. Replace k with n, then it is t of 0, because n minus n is 0, t of 0 plus n. So the time to take 0 elements is 1, that is nothing but n plus 1. So which is nothing but theta of n or order of n. So this is the time complexity analysis of factorial. Now we shall see another recursive program called as Fibonacci series in the next video. So the time complexity for Fibonacci series is 2 power n. So how to generate such kind of that means time complexity for Fibonacci series, and how to generate these kind of recursive functions, those things I'll explain in the next video, and in next video I'll give 2 tricky programs, so with a brief explanation. So next video will be very short, 15 minutes only. I'll explain the Fibonacci series in detail. So hope you understand the time complexity analysis for the recursive functions. Thank you for watching the videos. Please subscribe to my channel.